Okay, hello everyone. I really regret that, we cannot meet in person in Warsaw, but it looks like modern problems require modern solutions, and that's why we are here together in Microsoft Teams at the Microsoft 365 Saturday meeting. Today, I want to talk a bit about architecture of integration between our lovely product Dynamics 365 CE, formerly known as CRM, and Dynamics 365 Finance and Operations. If you have any questions, ask on chat, or we can simply talk after presentation. Okay, don't forget about our Bonner virtual bar, and also don't forget about raffle at the end of all presentations. Okay, 45 minutes for technical presentation is really not so much, and that's why if you need any information about me, just check LinkedIn, or we can talk after this presentation. All you should know that my whole IT career is associated with CRM products, and my last 8 years I have been working with different versions of Dynamics CRM and Dynamics 365. All right, just a short agenda here. We are here today to share our knowledge, and that's why I will talk about our current projects. It's a real battlefield because on one of our actual projects, one of them is in the middle of production deployment. And I will go through today our business goals, technical requirements of this project, architecture assumptions, and next we will discuss several issues that we may encounter on the way to victory, on the way to integrate CE and FO systems. Okay, our goals and assumptions. I know we are technical people. We don't like to admit it, but behind every technical solution, there is a business requirement. That's why we need a really short business intro. Sorry. Our client is international supplier with more than 2,500 users in shops around the world. It means that client need not only full Dynamics 365 FO with finance, logistics, retail, but also highly customized implementation of Dynamics 365 CE. Of course, this client also needs multiple integrations with third-party systems. Okay, really, that's enough business talking for one technical presentation. But why am I talking about it? Big projects like this are always separated into streams, and I'm responsible for one of the streams, FOCE integration. Okay, how we can summarize those business requirements? Enterprise solution, that's obvious because this company is really huge and they require enterprise solution for ERP, enterprise solution for CRM system, and that's why they also need enterprise solution to connect those systems. Both FO and CE are cloud solutions. One of them is more cloud-based, the other one cloud-hosted, but cloud is a cloud. And that's why we also want to build a cloud connector. Many CE to one FO requirement. I don't want to go deeply in this topic, but it's a typical international architecture with many CE and just one FO. And of course, open API. We don't want to only connect one point to the second point. we want to make this API open because in the future, some other systems might be able to connect to CE or FO with this API. Okay, and really that's all at the beginning. What about methodology? Almost all projects around the world are developed, implemented in agile methodology. Is it cool? Yeah, it's cool for both sides, but there is a problem always for integration team, because at the beginning of the project, where you have only few days or weeks to make first architecture, then, well, in most cases, and that's how it works in this project, we had no idea what will be the final number of interfaces, what will be the number of the requests per interface, and how big one request size can be. All we knew is that FO want to send master data to CE, vendors, products, etc. And CE want to, based on those master data, send transactional data to FO, such as sales order or purchase order. Okay, what about our architecture? I really believe that each good modern cloud integration solution should be built based on those four fundamentals. It should be scalable, of course, because if we build at the beginning something just for a few shops, for example, one country, and then we want to use the same integration for other countries, it has to be scalable. It should be serverless, because we want to create a cloud integration. And reliability and complexity. Well, we should really find a balance between reliability and complexity, because we want to make this integration with a maximum reliability, but we don't have to forget about complexity. We don't want to create our architecture too complex. We will come back to these points at the end to see if we achieved those points. Okay, before we will switch to the actual Azure components, just a little digression here. A little digression on the history of the CE and FO connector. I don't know, maybe some of you remember this product. It was created about 10 years ago, and it was a connector between CRM and Axapta. The good thing about this product, well, it works, but the bad thing is clearly all the rest, because this product had no triggers. We had to base on schedulers only. The performance was really poor. Logger, don't forget. We have to forget about the logger in this product. Error management, no such thing. And we could only connect one CRM to one Axapta server. Why am I even talking about this? Because after 10 years, Microsoft created new Power Apps FOCE integrator, and we made proof of concept about 11 months ago. And guess what? The same problems, no triggers, poor performance, poor logger. In most situations, we had no idea what the exact error means. No error management. We could only wait for another scheduler to execute to cross fingers, and maybe this record will go through to other system. And again, we could only connect one CE to one FO. So it's like a Back to the Future film. Of course, about 6 months ago, we had a small talk with Microsoft, and they said us that they improved performance, they improved logger. There is a chance that there are triggers now, but still, this product can only connect one CE to one FO, and we have no error management there. We should build this by our own. Okay, so we can't use standard product to connect FO and CE. What else we can use? Of course, Azure. Well, Azure is huge. Microsoft invested so much money that I'm really surprised that Azure is not serving a cup of coffee whenever I open Azure portal. The first contact with Azure can be overwhelming. Each component has own capabilities and limitations. It's easy to find the documentation and even tutorials about individual components, but we have to remember that those components have to, well, some of them have a native connections to other, and we have to also remember that just a one piece, one component isn't enough. It's really easy to find such documentation, but internet is full of materials, how to create app service in 5 minutes, how to learn Angular in 5 minutes. But if you want to find the full architecture materials based on real implementations, mission impossible. That's why today, based on our experience, I'm gonna tell you about a real example of CE/FO Azure integration. Okay, again, maybe just a small digression, because if someone will tell you to connect CE to FO, just one system to another, what would you do? You can just connect CE, you can trigger a plugin, you can send it to custom service in FO, and that's it. For second side, you can just trigger or batch on FO side, execute a batch, send it to CE API, voila, you have integration. But is it cool? Well, is it effective? Yeah. Is it scalable, efficient? No way. So maybe if Microsoft is talking a lot about these Azure components, we can just paste this component in the middle between CE and FO. Okay, that's better, that's reusable, but still, if there no other way, good other way to connect point E with point B. Okay, yeah, but we have to learn a bit about difference between sync and async integrations. Why we are using sync integrations? Most cases because it's simple, and because if someone will click a button on FO side, he just have to wait a second or two or maybe longer, and after that there is a response with a proper response or an error. So business in most scenarios just don't want to wait for a response. They don't want to refresh site, they just want to click, and after a second or two they have a response. But to be honest, async integration is better. Why? Because Microsoft said so? No, because really async integration is considered to be more reliable and scalable than sync integration. Regardless of the traffic generated by one system, you can process information in the other system at the speed and efficiency you choose. Load balancing, performance, scalability, if you need this, probably you should use async integration. So, quick summarize, if you can choose async, if you really have to choose sync integration. Okay, and just a quick info about our technology. Of course, as everything on backend in CE, we used C# with .NET Framework, which is easy to connect to CE, and we also use .NET Core in our Web API components. Of course, we decided to use REST API with JSON files. And just a, short intro to Azure components. At the beginning, we decided to use those 5 components. Service bus, it's just a, cloud messaging service. Function app is a service, serverless service to run on-demand functions. API management, routing, telemetry, documentation for all services in the project. App service, it's just typical place for our REST API services. And last but not least, application insights. It's a really powerful analytic tool to diagnose issues, but to be honest, just this one tool requires a full-time presentation. Okay, that's our first architecture. That's what we built at the beginning. Let me tell you more about this flow. On the left side, we have our lovely FO product. And for example, based on a trigger on a batch, FO post a message on the service bus queue. And service bus just immediately respond that he accepted this. And that's all. FO has no other information about this message. So FO can even send thousands of records, put it on the service bus queue and forget about it. All other is in Azure. Other next important component is our app function. We can call it listener in this situation because it's listening, is there anything on service bus? If listener could found something, it use get request to get this JSON request sent earlier by FO. Then listener can synchronously send this message to our app service, which is connected directly to our CE, and based on create or update method, we have information on CE side with success created or update with proper REST API code. App service is sending back it to listener function, and listener function can release log on this message on service bus. It's just our first architecture. We decided that, its reliability of this architecture is good enough, and it's not too complex at the beginning. Okay, now I want to talk a bit about our road to victory, about road to make this architecture real in this project. The first challenge we found the request size, because service bus is just the best solution when we need something for management of message on the queues. But there's a real problem because in this project we realized that a request from FO can be even higher than 2 megabytes. And service bus can only, even on premium tier, can only handle 1 megabyte file. To be honest, sometimes when reading Microsoft documentation, I have the impression that the authors are competing in who will put a better Easter egg in this doc. Look here, due to the system overhead, this limit is less than these values. No idea how big this request size is real in real life. Okay, so what else we can do? We can't just put a 2 megabyte JSON file on our service bus queue. What we can do? We can use Azure Blob Storage. So how it looks like in real life? FO just, as earlier, and message on the QE, but the JSON file connected to this message is posted on blob storage. And our listener, when listener finds something on a QE, then he can download a request from blob storage. Everything on app service and CSide connection is exactly the same as at the beginning. Okay, but that was just an easy problem to solve. Second problem, duplicates. When you create a sync integration, you can use something called singleton pattern. You can just execute one request after another, and there is no problem with duplicate because the second request is executed after the first, no problem. But when we build an Async integration, we want to make it parallel. Azure components, especially app function on Azure, can create many instances, and every instance can create many parallel threads. So if we have 5 app functions with 4 threads, in the same time we have 20 app functions which can retrieve in the same time 20 requests from our blobs app service, bus QE. And if we find there, for example, the same request with the same product, our app service will create the same number, the same records on CE side. So how we can handle this? We can use something called upsert method and keys on a CE side. We decided to create a key on every entity integrated on CE side. And then, as you can see here, we can easily use this upsert method with key attributes. What is an upsert method? It's create and update in the same time. We are sending this upsert request, but the server decides is this record really was earlier created on C side or not. If it was created earlier, then system just execute update method. If it's a new, then there is a create. One important thing here, when we create a key on C entity, there is also created index in a database. So every query can be a little faster. Okay, but again, duplicate problem is a real problem, and we have to handle it. It requires a lot of change in our API if we based only on create and update methods. But in our architecture, big picture, the modification in API is small. We just decided to change create or update to use upsert method. All right, now we will talk about a real problem here. Common data service limit. Maybe you know about it. There exists a limit that one user can only execute up to 6,000 requests in 5 minutes. Is it a big number? Well, if you just click in the system, no problem. This limit is not a problem for you. But if you want to integrate something, then 6,000 in 5 minutes, it's not a big number. I know why Microsoft made this limit, because CDS isn't a warehouse, and there was a lot of vendors who thought that they can use this cool system to create a warehouse for payments and other big entities. So, okay, we have this limit. The problem is, again, Easter egg here. These limits are subject to change and may vary between different environments. So 6,000 may be less. We don't know. Second problem, if FO, for example, send us this simple product JSON, can we create 6,000 records in 5 minutes? No, because we need one abstract method to create this product. We need at least two shots to common data service to associate this product with vendors. Next one to connect a category with this product. As you can see here, we have a business unit. We have to find a GUID number on C side of this business unit. We have unit of measure. We have to check what's the GUID or the number of dictionary on C side of this unit of measure. So every request sent to from FO to C does not mean it's one shot to common data service. In this example, we need about 6 requests to create or update this record on C side. And that's why 6,000 is not a real number. In our implementation, we are able to make up to 1,000 per 5 minutes requests. Okay, so this problem can occur if we are sending something faster than this 1,000 per 5 minutes. And if we encounter this problem, what we can do? Microsoft decided we should just wait. Okay, we should just wait another 4 or 5 minutes for next 6,000 limit. But can we make this? No, because if we use serverless app function and app service, we can't keep connection between our serverless components longer than 4 minutes. Why? Microsoft decided that this is generally a reasonable response time limit. Okay, so we should wait, but we can't wait. So what we can do? Microsoft again decided that we should reschedule this message. So if we have this exception that we have a limit, we have to wait, we added a reschedule functionality to our flow. How it looks like. Okay, so the beginning is exactly the same. We are trying to execute abstract method on C side, but this time we have an exception, API limit 4 to 9. That's the exact result code of this API limit exception. Our app service is returning this error to our listener, and listener just reschedule this message on the queue. And after a few minutes, we can get this request again, post request to app service. App service is trying to create or update on C side, and that's correct because now there is no limit. We could wait 5 minutes, and now we have no limit problem. Is it cool? Is it the only way how we can make it? No, for sure we could make other changes in our architecture, and well, I'll try to tell you a bit about it at the end of this presentation. Okay, next problem. So far, we only talked about, well, positive option. If everything is all right, or we just have an API limit, it's still a proper situation. But we want to build something with as high reliability as possible. So what we should do? We should create something called retry policy, because no matter how good your solution is, error happens. Timeouts, connection issues, component can restart, Azure failures. Maybe you remember a few days ago this huge problem with Azure authentication. So we have to handle it. We have to prepare our implementation for it. If you have a sync integration, no problem, because user can see an error in a real time. If it's async integration, only an admin or developer can check what's the problem after even few hours. It's too long. We have to build something to retry those standard problems like timeouts. To be honest, it's really simple in Azure, because our app function, which retrieves messages from the queue and executing everything on C side, this component we can add to this component just few parameters, few settings to decide which exact retry, which exact error code we should retry, how many times we should try to retry this message, and how long we should wait between first and next request execution. I just added a few lines of code. Well, it's not an exact our implementation, but it can give you an information how easy it's to make this retry policy on Azure. Okay, so how it looks like on our flow. Again, the beginning of this is exactly the same, but we are trying to make upsert on C side, and we have a timeout, standard 2 minutes timeout on C side. When we have this error, which we configured in our app function can decide to reschedule this message on the queue, and then after 60 seconds, second shot. We want to make upsert again on C side. Again, we have timeout. So third shot, again, timeout. So because, well, if it's a timeout, in most situations, if you retry this message, second shot will be correct. But what if not? How can we handle situation if even after 3 shots we still have an error? Microsoft prepared a special place for such a request. It's called dead letter queue. It's a special component on our service bus. So after 3 attempts, we decided to put this message on dead letter queue. And well, there is one problem about this component. There is no tool in Azure to do something with messages on dead letter queue. Okay, so what else we can do? Because so far we just talked about our positive way how to handle something. We said about retry policy when automatically we can retry a message. But still, it's not everything. We have business error. We have errors which after 3 tries, still we have an error. So what else we can do? We should prepare our architecture for a client. We should remember that this architecture, this solution should be prepared for business guys. So the error management shouldn't be only on technical people. We should prepare tools for a client so even business guy can check is it working properly or not, what else he can do. How can we make it? Of course, application insights. As I said earlier, it's a really big solution, and we need a single full-time presentation to talk about only this one tool. But still, we can create a dashboard there when, for example, here we can check what's the number of failed messages according to all messages sent from one system to another. We can check exactly what was the error. We can check a full JSON file there and send it to developer to check what was the real problem. But as I said earlier, there is this one problem with dead letter QE. So after three error attempts, we have this message on a special QE. How we can check it? We decided to build a special custom portal for it. Some business guy can just open this portal and he can check what message is currently on the main QE, what is currently executed or scheduled, and also he can check what's in our dead letter QE. And he can check what was exact product, what was the problem with this product. He can retrieve logs from application insights, and he can decide to delete this message because, for example, there is a configuration problem on FO side, or he can show full body of this message and resend this message on the QE. All right. I just talked about few issues, few challenges we found on this project we had to encounter. But to be honest, it's not everything. As I said earlier, building such a big architecture is a challenge, and you encounter a lot of other problems. For example, if you find an error code 0 in your application insights, you should increase HTTP timeout. If your message is executed few times, the same message on the QE, don't forget about something called service bus log timeout. If you want to manage in a secure way access to Dynamics 365, use Key Vault. Okay, so let me just go back to our 4 points which I showed you at the beginning. So is our implementations, our architecture product scalable? Yes and no. Azure, for sure. Azure is extremely scalable. CDS, not really, because we have this limit per one integration user. We can create up to 1,000 records per 5 minutes. It's a real problem. But of course, in different countries, we can use different tech users. Every user has his own limit, so we can increase we can prepare our scalable implementation. What else we can do? We can change listener to execute batch requests, because now listener in our architecture is just retrieving one request after another, and we can decide to just get, for example, 100 requests in the same time, and then execute everything as one execute multiple method on the C side, because the special execute multiple method is counted as one execution on CDS limit. Okay, is it serverless? Of course, Azure serverless components in 100%. And what about reliability? I showed you earlier that we handled retry policy, we handled errors, standard errors like timeouts, and that's how we made our retry policy. But what about business errors and timeouts? How about other problems? I showed you earlier this small screen. As you can see, 91 errors in 42,000 of records. Almost all of them, 91 errors, it's a business error. And some business guy just have to log into this dashboard and check, oh, okay, I forgot that we didn't add some kind of configuration FO site. That's cool. Only few errors here. We had timeouts or connections issues, but our retry policy just handle it. So yeah, reliability of this architecture is really good. What about complexity? Yeah, I know that when you probably if you had no occasion to hear about Azure components, then the complexity of this architecture can be a problem for you. But to be honest, all components which we used can be just click, click, click in about 1 hour. And that's Azure Service Bus, API management, Azure Blob Storage, that's all no-code components. You just have to install and configure them. What's about code? Well, our listener is, of course, a bunch of line of code, but I think it's about 100 line of code. That's everything you need to prepare a good listener. The only complex component here is our app service, our REST API. But if you create sync integration, you need exactly the same component. So for me, after all months when we prepare this, I don't really think it's a complex architecture. The only real complex thing here is to find your own architecture that meets your technical and business requirements, your own way to victory. That's everything from my side.